The second part of 2.1 is determining domain of a function. We're not as concerned in general once we get to this level of mathematics about the range of a function, but we're very concerned about what values x can possibly be, okay? So once you've identified a function, it is very important to find the domain of the function, okay? Most of the time we're gonna be doing this without a calculator, okay? So you gotta make sure that you're talking about the function and you're only talking about the function where it exists, okay? So trying to determine where the function exists is very important, okay? To figure out the real domains, so we're not so concerned about imaginary places, but the real domains of the function when we're just looking at the function and don't have a graph, we're really looking for values of x that don't work, okay? So we're looking for functions that don't work. So these are essentially the three places that things you need to look out for. The first one, division by 0. So the bottom of the fraction cannot be 0. Okay, so you're looking for the bottom of the fraction. If there's a number that makes the bottom of the fraction 0, that is a place that the domain does not exist, okay? If you're talking about even roots, so a square root, a fourth root, a sixth root, any of those, even roots, you cannot take those of negative numbers. So if you've got a square root of something, that something has to be greater than 0. Okay, that something has to be greater than 0, all right? So you've got to set this equation up and solve this inequality, all right? You also can't have logarithms, and this is a very rare case, you can't have logarithms that are negative. So if you have like the log of like -2, that's not a thing. So that's a place that the function would not exist either. So you would have to, again, do this setup and find where that thing is greater than 0, okay? So those are the things we're looking for. Fractions where the denominator is 0, roots where the inside has to be positive, and logs where the inside has to be positive. So take a look at example 4. I don't care so much about the top of a fraction as long as there's not a square root. So there's no value of x that I could plug into the top that I can't multiply by 3 and get a number. So this is gonna work all the time, all right? Looking at the denominator though, I know that this is a not a quadrilateral, I know that this is a quadratic, and I know that I can factor it. So the denominator, if I factor it, is really x plus 3, x minus 2. So when we did the zero product property earlier, we found that these two things multiplied together are going to equal 0 when one of them is 0. So if this term right here, the x plus 3 is 0, that would mean that x is -3. And this term will be 0 when x equals 2. So when either of these numbers happens in the denominator, that means the denominator is going to be 0. So that means that these two values cannot be values of x. So you might write down that the domain is where x does not equal -3 and 2. It works everywhere else except for those numbers. So you could write it this way. And the other way that you could write it is in something called interval notation. And interval notation is the thing with the parentheses and the brackets, which hopefully you've seen before. I know that they cover it in Algebra 2. So remember, the parentheses are the same thing as the less than or greater than signs, either one of those, but not the or equal to. And the brackets are less than or equal to or greater than or equal to. So these are the or equal tos. So this domain could also be written as all of the numbers from -infinity to -3. This symbol means union. So it's kind of like the notation version of and. So it's this set of numbers and all of the numbers between -3 and 2, not including -3, that's why I use the parentheses, and all of the numbers past 2 to infinity, but not including the 2. So either of these two notations would be correct. So this would be like normal fast notation. This is what I would use on the AP test for like domains of things where there's just one or two numbers not included. But this is what it would also look like in interval notation. So it's this interval and this interval and this interval. So not the 2 and not the -3. Okay? Looking at the next one, again, there's no square roots, there's no weird things in the top, so we're good. But look at the denominator. The denominator factors. This is a difference of two squares, so this is x plus 4, x minus 4. So this tells me that x cannot be -4 or +4, which they're most of the time write this way. So this would be the domain. Or if we were going to write it in interval notation, we would go from negative infinity to negative 4 and negative 4 to 4 and 4 to infinity. Okay, and again, this symbol is a union. It just means and. So I'm going to start saying union now, okay? So h of x on C is this, and we know, okay, this one doesn't have a denominator, so I'm not worried about the denominator going to 0, but I am concerned about this piece. So I know that with a square root, because it's an even root, this piece has to be positive. It's got to be greater than 0. So I'm going to set that up because I know it's got to be greater than 0 and just solve that. That's something I know how to solve. So 2x is greater than 3, so x has to be greater than 3/2. Okay, that looks like a good domain to me. X has to be greater than 3/2. That makes sense. If you were going to write that in interval notation, can the x actually be 3/2? Well, this equals 3/2 at 0, so I guess we should have put the inequality symbol or equal to on there, because if you plug in 3/2, you're going to get 0, and that's okay. I just need it to be greater than or equal to 0, okay? So make sure you correct that in your notes. Make sure it's greater than or equal to. So x has to be greater than or equal to 3/2. Well, if we're going to write that in interval notation, it can actually equal 3/2, so that's where we're going to use the bracket. So this is bracket 3/2, and it's greater than that, so it goes to infinity. And infinity, if you remember, always gets a parentheses because it can't ever actually equal infinity. Okay, look at letter D. Letter D works the same way. This piece right here, 3 minus 5x, has to be greater than or equal to 0. Okay, so I'm going to solve it again. This time I'm going to move the 5x over. You know I like to keep my x's positive, so this is 3 is greater than or equal to 5x. Then I'm going to divide by the 5. So this is 3/5 is greater than or equal to x, okay? And when I write these, I always like to put the x's on the left. So let me flip this around. Make sure you keep the arrow of the inequality sign pointed at the right thing. So it was pointed at the x, so I need to keep it pointed at the x. So this says x is less than 3/5, okay? So this time 3/5 is my upper boundary, so it can't be more than 3/5. So I'm going to go from negative infinity to 3/5. The negative infinity we can't ever actually reach, and the 3/5 is or equal to, so I can have a bracket.